8. Oops. Okay. What is metallic bonding? So that's actually quite a loaded question here. But in simple terms, right? There's 3 types of bonding, okay? And 2 of them you're quite familiar with because it's always discussed. There's ionic, covalent, and as they said, metallic. Now, for an ionic bond, typically for it to happen, it's a metal bonded with a non-metal. Okay? That's how it works for ionic bonds. Now, covalent bonds, typically, it's a non-metal bonded with a non-metal. Okay? So now we have an option of metal and non-metal, non-metal and non-metal. So what would metallic bond be? If you probably guessed it, it would indeed be a metal to metal bond. Okay, it's one of those that are like not as discussed because most chemistry focus on like the ionic or covalent bonds. But metallic bonding is there, and there are many real-world applications. Like when you look at steel, for example, that is a combination of different metals. I'm trying to think of other ones like even like copper. No, let me check the periodic table. You see, so I'm going to just refer to it. No, copper is a whole element by itself. But yeah, steel is a perfect example I can think of, really, just because it's like honestly one of the perfect showcase of metallic bonding. And if we were to go ahead and organize this by what you typically find for the boiling point, covalent bonds would be the lowest because they are the easiest type of bonds to break. Ionic bonds get pretty high, but metallic bonding, as you notice with steel, for example, are really hard to take apart. Like you need extremely high temperatures for it to melt. Well, for it to boil, actually. Like insurmountable amount. It's very intense. But yeah, so that's how it works. Metallic bonding is typically the strongest type of bonding, and it's when it's between a metal and another metal. Okay. So, this is a nice picture as well of what you kind of represent when 2 metals are hanging out together. You see a lot of positive ions and the electrons from both of them that kind of just surround them like a sheet. Okay? So exactly. And it is different from the typical ionic or covalent bonds. Because as they mentioned here, actually, they're like, in a sense, involved in like forming quote-unquote bonds. They just kind of float around in that vicinity, creating this like ion-electron-ion type of exchange in this sheet. Okay, so this right here is metallic bonding, and that is how you break it down. Let's see what else it says about it. Strong attractive forces, yep, the strongest one most likely, and that's why it has a high melting and boiling point. Yep. And this also goes on to mention like different properties of when 2 metals are bonded. As they mentioned, malleability, the way you can change the shape, because most if you notice like ionic bonds and covalent bonds, they usually come in the form of like salts, especially for like ionic bonds, for example. So exactly, so metals and conductive properties. So exactly, can even like conduct electricity as well. And exactly, there's pure metals such as gold. So gold is the reason why they're using it is because, like as you see, like gold bars, for example, that technically counts as like metallic bonding as well, because exactly, it's a lot of gold atoms in a sense coming together to form that sheet of, you know, electrons and gold. Silver, same thing, and alloys. That's what they're called, alloys. So mixtures of different metals. That's also what we'll do there as well. Okay, so that's all we have here for specifically metallic bonding, correct? Now let's go on to question 9. Okay, sorry about that.